Yes.
100-year-old grid, you have generators that are steam driven because of gas turbines or coal. So there is a rotating mass, and the sheer inertia just makes it keep on going. In the last few decades, as we have moved towards the renewables, like solar and wind, batteries become very, very important. In order to get that type of power to the grid, we use electronics, and it's typically called the inverter, because they start out as technically it's a direct current, and in the grid we need alternating current. So the inverter does exactly that. And inverters are built with semiconductors. And semiconductors work very, very differently than the copper and steel and wire. In electronics, you're walking on thin ice because these chips are so small that a little arc just blows the thing up. And it goes really, really fast. It's like less than a microsecond. So you have a very harsh grid and a very sensitive semiconductors. And the cost, you can make it more robust, but there's an exponential cost to make semiconductors be rated at higher voltage than they normally operate, just in case there's a spike. The saying is, oh, there's no moving parts, it should live forever. Well, that's a fallacy. It's actually the opposite is true. We actually monitor those disturbances and find out what stress has it caused on the electrical component. How close is this to a failure? We can raise an alarm saying, it's time to replace that element that is stressed out.